Alright, here we are. I'm calling this part 2. These are the absolute value, but they're inequalities. So, with inequalities, you're going to either have a greater than or equal to, or a less than or equal to. The greater thans are equal to slightly more complicated, not a heck of a lot. But here's the deal. Let me walk you through this. And notice he asked me to solve it, and then if you notice the answers are all in interval notation. So what I'm going to do once I solve it, I'm going to graph it and then take the graph and then translate that into a interval notation. So we have the absolute value of x is greater than 9. So with the greater thans are equal to, this is what I have to do. I start out by saying this. X is, notice I reverse this to less than, and then I use the negative of whatever number I have here. X is less than negative 9. I reverse this to less than, I change that to a negative. Or I simply drop the second part of this, I simply drop the absolute value and I just write it just the way I see it. X greater than 9. Alright? So the only part that's a little different, you reverse this and then you use the negative of whatever number you have there. So in actuality, I'm done here. I can just kind of graph this and then translate that into here's my negative 9, and here's positive 9. I got values of x that are less than, strictly less than. Alright, so all the way out to negative infinity, and union with values of x that are greater than 9, all the way out. So what have I got here? Interval notation from negative infinity, comma, to negative 9, brackets, parenthesis, because it's a strict inequality. Alright. Union with, I'm taking all these values, these values, union them with all the values that are from 9 all the way out to infinity. Once again, I'm using parenthesis because it's a strict inequality. All of these values less than negative 9 and all these values that are bigger than 9. And if I look at this, I see letter D. Number 9, this one here is a less than or equal to situation. I feel that these are the easiest. Here's how I accomplish this. When I see a less than or equal to, I start out by using the negative. I keep this going in the same direction. I drop the absolute value. I keep this going in the same direction, and I use the positive. Alright, that's how you set up the less thans or equal to. You take the negative on the left, you take the positive on the right, and the x falls in the middle. So, here's what I've got. I've got values of x that are between negative 10 and positive 10 included. So, drawing something, here's negative 10 and here's positive 10. I've got a bracket here and a bracket there because it's less than or equal to, less than, and everything that's in between negative 10 and positive 10. Interval notation, I'd have a bracket, negative 10, comma, positive 10, and another bracket. And as you can see, number 9 is letter C. Alright, letter C. This is what I've got. Bracket. You know, could we play games where we could say to ourselves, yeah, this is a parenthesis, but see, when you deal with negative or positive infinity, you're going to have parentheses, so I can't play that game. So sometimes you just want to you can't be too cute. Just do the problem out and let the chips fall where they may, so to speak. I mean, you take shortcuts, but sometimes you can outfox yourself. Number 10, absolute value of x is less than or equal to 4 8/10. Alright, here's what I do. With the less thans are equal to, I take this number on the left-hand side. I use the negative. I keep this in the same direction. There's my x. I keep this in the same direction, and there's my positive. Alright? And the idea why we're doing this is that absolute values, if this number is negative, it has to become positive. This is why we're using both negative and positive. So I'm done here. I've got brackets because these are not strict inequalities, less than or equal to. And I got values between negative 4.8, comma, and positive 4.8. Everything that's in between these two. If I look at this, obviously it's, not obviously, but letter C, all values between negative and positive. Interval notation, that's how I would write it. Negative on the left and positive on the right. Alright, so the first three were pretty straightforward. In fact, this number 11 is also pretty straightforward. It's not till we get to 12, 13, and 14 where we got to do a little bit more work. Number 11, I've got the absolute value of 4x is less than 3. A less than, I like these. Alright, so less than's or less than's are equal to. I take the opposite of that. Negative 3. I keep this in the same direction. I drop the absolute value, keep this in the same direction, and I use the positive 3. Now, unlike the previous ones, I don't have x. I've got 4x. So I need to know what x is, right? How x relates to all this. So I'm going to divide everything through by 4. Left-hand side and right-hand side. 4's cancel out. I get a negative 3/4 less than x, which is in turn is smaller than a positive 3/4. Alright, so first thing I know, I've got strict inequalities. I want everything between a negative and a positive 3/4. So between negative 3/4, comma, and a positive 3/4. Everything that's in between those two values, and that's how I would. Here again, I've got parenthesis because of the fact it's a strict inequality. And number 11, we've got letter C here. Parenthesis, negative and positive. Alright, pretty straightforward. Number 12 is, alright, now this gets a little more work involved. Absolute value of 9x minus 6 is greater than or equal to 1. Now with the greater than, this is what I got to do. It's a little difficult, a little more complicated. Alright, so here's what I start out doing. I start out saying that 9x minus 6, the thing in the absolute value, I switch this around from greater than or equal to less than or equal to, and I use the negative. Or, the second part of this is pretty straightforward because I just write what I see without the absolute value. Alright? I'm just writing exactly what I see here except for the absolute value. This is the part that you got to remember. It's this, you switch this to less than or equal to, and you use the negative of whatever number they provided you here. Alright, so now I got to solve this. Alright, so what I'm going to do is to bring the 6 over as a positive. 9x less than or equal to negative 1 plus 6. 9x less than or equal to a positive 5. Come on, Mr. Gomes. Negative 1 and positive 6 is a positive 5. And then I'm going to divide both sides by 9. And x is less than or equal to 5/9. Okay. So, or, solving this right side, I'm going to bring the 6 over as a positive. 9x is greater than 1 plus 6. 9x greater than or equal to 1 plus 6 is 7. Dividing both sides by 9, the 9's cancel out. X is greater than, this is an or situation, or 7/9. Alright, so on the number line, I could draw, I guess, drawing number lines are my forte. We call this 5/9, and we call this guy 7/9. This is negative infinity, and this is positive. X values are less than or equal to 5/9, less than or equal to. So I got all these values that are less than 5/9, or X values that are greater than 7/9. So a bracket here, and everything that goes out to infinity. So how would I write this in interval notation? Well, negative infinity is always associated as positive infinity with a parenthesis. 5/9. Here again, this would be a bracket. Union with. Union means I'm taking all these values and I'm adding all these values on the right side. So I got a bracket here because of 7/9. And comma all the way out to infinity. Infinity is associated with a open parenthesis. So this is number 12, and if I look at this closely, number 12, it sure looks like letter A to me. So that's the one up to now took us the longest to do. All right, and half the battle was because of the greater than. You had to do all this, but the idea is, you go step by step. Don't do things in your head. Just take one thing at a time. All right, less than. I prefer less than better than greater than. I think they're just that much easier to do. But you're going to see both. Absolute value of 6x plus 3 is less than 3. I like the less thans, and the less thans are equal to. I take the negative of this number. I keep this in the same direction. I drop the absolute value symbol. I keep it in the same direction. I just write the positive. This right side here is just that without the absolute value. The only thing you're doing here is using the negative, but keeping this in the same direction. All right, your goal is to get x by itself. All right. Before you get x by itself, you need to get 6x by itself. How do you get 6x by itself? You deal with this add 3. The inverse of adding 3 is subtracting 3. I'll subtract 3 all 3 spots. A negative and a negative is a negative. Negative 6. Less than, these guys cancel out. 6x, which in turn is less than 3 minus 3, well, that's 0. So my last step in getting x by itself is to negate this multiplication by 6 by dividing everything through by 6. Negative divided by a positive is a negative 1, less than, the 6's cancel out, x, 0 divided by anything is just 0. So what have I got, just to make sure it's a strict inequality? I've got parenthesis, everything between a negative 1, comma, and 0. Between negative 1 and 0. And this is number 13. Number 13 and letter, you can see it. 13, oh, here it is right here. All right, I get it right here. Between open parenthesis, between negative 1 and 0. Between negative 1 and 0. Alright. And this last one, it's a greater than, not a big issue. Absolute value of 4x minus 9 greater than or equal to 5. Alright, since it's a greater than or equal to, doesn't make a difference. The idea is greater than. Here's what I do. I start out by saying 4x minus 9. I reverse this. Greater than. Alright, I reverse this. Well, yeah. If I reverse it. If I reverse greater than or equal to, I've got less than or equal to, and I use the negative of this number. Okay. Or I just simply copy down what I see without the absolute value symbol. 4x minus 9 is bigger than or equal to 5. All right. So I wrote this down, I reversed that, and then I used the negative of this number. And the reason I'm doing that is it's a greater than or equal to. And then the second part of the or statement, I just drop the absolute value and just basically write down what I see, keeping this in the same direction. All right, I need to solve for x, so first thing I'm going to do is add 9 to both sides. So 4x is less than minus 5 plus 9. 4x is less than or equal to 4, dividing everything through by 4. 4's cancel out. X is less than or equal to 1. Funny looking 1, or solving for x here, adding 9 to both sides. 4x greater than or equal to 5 plus 9. 4x is greater than or equal to 14, dividing everything through by 4. 4's will cancel out. X is greater than or equal to 14 over 4 to lowest terms is 7/2. Alright, so in interval notation, what have I got? Let me just kind of graph this to get a better picture. Alright, here's my 1, and here is 7/2, which is what, 3.5. I get x values less than or equal to 1. Alright, so I got a bracket there, and everything is less than, all the way to negative infinity. X values greater than or equal to 7/2. So everything here all the way out to positive infinity. So if I draw the graph, then rewriting this in interval notation, it becomes more simplistic. So negative infinity is always associated with a parenthesis. There's my 1, but it's including 1. So it's a bracket union with. Take all of these and add all of those. Here again, I got a bracket there because I'm including less than or, I'm sorry, greater than or equal to. So it's a bracket, comma, all the way out to infinity, which is always associated with a parenthesis. And 14, if I look at it, boy, it sure looks like it's letter B to me. Sure looks like. So take some time. Hopefully that helps you.